Hello and welcome. This module is dedicated to exploring constants in C++. In this video, we're going to learn how to create and use immutable values in C++ programs. By the end of this module, you'll understand how to define and utilize constants effectively, ensuring that certain values remain unchanged throughout your program's execution. C++ constants can be classified into two main categories: literal constants and symbolic constants. First, we will discuss literal constants. Literal constants are fixed values that cannot be altered during the program's execution. Examples of these include 100, 3.14, the character a, and the string hello. These values are used directly in expressions and come in different types such as integer, floating point, character, and string. Secondly, we have symbolic constants. Symbolic constants are named constants that hold fixed values. These are created using the const keyword or the #define preprocessor directive. Symbolic constants improve code readability and make maintenance easier by allowing you to refer to a value by a meaningful name. Now let's delve deeper into literal constants. Here are some common types of literal constants with examples. First, we have integer literals. We can declare an integer a and assign it a decimal value of 10. Similarly, we can declare an integer b and assign it a hexadecimal value of 0x1a. An integer c can be assigned an octal value by prefixing the value with a 0, such as 012. Finally, an integer d can be assigned a binary value, such as 0b1010. Next up are floating point literals. Here we declare a double variable named pi and assign it the value 3.14159. Next, we have character literals. To define a character literal, we declare a char variable, such as ch, and assign it a character value enclosed in single quotes like a. And string literals. A string literal is a sequence of characters enclosed in double quotes. In the example, we declare a constant character pointer str and assign it the string hello. Alternatively, we can use the standard string class to create a string object, cpp_str, and assign it the value world. Lastly, there are Boolean literals. To define a Boolean literal, we declare a bool variable, such as flag, and assign it either true or false. Now let's see how to create constants using the const keyword. The const keyword is used to create variables whose values cannot be changed after initialization. This ensures that the value remains constant throughout the program's execution. For example, we can declare a constant integer max_users and assign it a value of 100. Similarly, we can declare a constant double pi and assign it the value 3.14159. A constant character grade can be assigned the value a, and a constant standard string, app_name, can be assigned the string myapp. Once a variable is declared as const, any attempt to modify its value will result in a compilation error. For example, if we declare a constant integer buffer_size and try to assign it a new value later in the code, the compiler will throw an error. Also, constants must be initialized when they are declared. Declaring a constant without initializing it will also result in a compilation error. The benefits of using the const keyword includes it prevents accidental modification of the constant, allows for compiler optimization, and makes the code more self-documenting. Next, let's explore how to create constants using the #define preprocessor directive. The #define preprocessor directive is used to create macros that are replaced by the preprocessor before compilation. This is an older method of defining constants in C++. For example, to define a constant max_users, we can use #define max_users 100. Similarly, we can define pi as 3.14159 and app_name as myapp. These macros are then replaced by their values before the code is compiled. We can also use #define with expressions to create more complex macros. For example, we can define a macro square x as x asterisk x to calculate the square of a number. Similarly, we can define a macro max a b as a greater than b (colon b) to find the maximum of two values. Now let us compare const and hashtag define. Const involves type checking, while hashtag define does not. Const follows scope rules, whereas hashtag define has no scope and is global. Const provides better debugging support, while hashtag define has limited debugging capabilities. Let's explore modern C++ constants using constexpr. Constexpr specifies that the value can be computed at compile time, enabling better optimization. This is a more modern and efficient way to define constants in C++. For example, we can declare a constexpr integer max underscore buffer and assign it the value 1024. Similarly, we can declare a constexpr double golden underscore ratio and assign it the value 1.618. Constexpr can also be used with functions. For example, we can define a constexpr function square int x that returns the square of x. This function can be evaluated at compile time if the input value is known at compile time. When comparing constexpr with const variables can be initialized at runtime, while constexpr variables must be computable at compile time. Constexpr can be used in template parameters, while const cannot. For example, we can use a constexpr variable to define the size of a standard array. C++ 14 and later versions allow more complex functions to be declared as constexpr. For example, we can define a recursive function factorial int n that calculates the factorial of a number. The features of constexpr are that it is evaluated at compile time, enables compile time computations, can be used in template parameters, and improves runtime performance. Let's summarize the best practices for using constants in C++. When it comes to choosing which method to use, it's recommended to use const for most symbolic constants. Use constexpr for compile-time constants and computations. Avoid hashtag define for constants in modern C++. Follow the all_caps naming convention for global constants to clearly indicate that they are constants. Group related constants in namespaces or enum classes to improve code organization. Here's an example of grouping related constants in a namespace. We define a namespace config and declare constant expressions like max_users with a value of 1000, timeout_ms with a value of 30,000, and a constant standard string version with the value 1.0.2. Now let's see the common pitfalls to avoid. Avoid using magic numbers directly in code. Instead, use named constants to improve readability. Be cautious with macro side effects when using hashtag define. Remember that const pointers need const keywords for full immutability to prevent modification of both the pointer and the value it points to. Avoid overusing global constants. Prefer scoped constants to minimize potential naming conflicts. Ensure constexpr functions remain simple for compile time evaluation. Constants improve code readability, maintainability, and can enable compiler optimizations when used correctly. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.